Assalamualaikum, peace be upon you all. So we're going to continue about first order logic, which is the rules of quantified inference. Okay, in a previous lecture, I have introduced this term universal instantiation, universal generalization, existential instantiation, and existential generalization. Okay, so we are going to look further into each of these. So what is universal instantiation, or basically universal elimination? We can eliminate or delete the universal quantifier. Okay, so we want to make the x, okay, or the variables more specific. We didn't say for all x anymore. So what is the condition? If all x, px is true, then pc is true, where c is any constant in the domain of x. Okay, the value is already defined in the knowledge base. Okay, so we can actually delete the quantifier here. Okay, for example, for every x, okay, where Ziggy eats x, okay, then Ziggy eats ice cream. So we already specify that x is an ice cream in knowledge base. Okay, so the variable symbol can be replaced by any ground terms. That is any constant symbol or function symbol applied to the ground terms only. So in this case, we know, okay, in our knowledge base that we have list of food that Ziggy eats. Okay, so we have I see, for example, in the knowledge base, we know that Ziggy, say that Ziggy is a modern or future robot. Okay, and we need to know what are the things that Ziggy can eat. So we have ice cream, for example, we have chocolate, alright, and also rice. So Ziggy only eat 3 things. Okay, so if we make this sentence, every x where Ziggy eats x, then Ziggy eats ice cream. So we already have a list of things, okay, for what Ziggy eats. So in this case, you can eliminate the universal quantifier. So we make the x as more specific. Alright. Okay, next is existential instantiation. We want to eliminate the existential. Okay, eliminate this symbol. Okay, so from some x, okay, some x, x is p, is infer p to c. For example, Ziggy eats some x, then Ziggy eats stuff. Okay, so note that x is replaced by a new constant, okay, not occurring in this or any other sentence in knowledge base. So this is not, stuff is a new thing. Okay, we don't declare it in the knowledge base. So this is also known as a columnization. Okay, a constant that is a column is a column. So why do we do this? Okay, we don't want to accidentally draw other inference about it by introducing the constant. Okay, so we take off this some x here. Okay, so we don't simplify add any constant into things that Ziggy eats. Alright, in our knowledge base. Okay, so if you have this, you can easily add anything here into things that Ziggy eats. Okay, so it is convenient to use, okay, to reason about the unknown object, okay, rather than constantly manipulating the existential quantifier. Okay, and then we have existential generalization, okay, or the existential introduction. Okay, so we introduce the sum form. Okay, we introduce the. So if px is true, then sum x, where x is p, is inferred. For example, Ziggy eats ice cream, then we can say for sum x, Ziggy eats x. Okay, so all instances of the given constant symbol are replaced by the new variable symbol. So we generalize the specific constant into x. So it's the other way around of you delete the existential. In this one, we introduce the existential. Okay, why? we add the existential generalization because we want to make we generalize the specific constant. We want to add that into the current knowledge base. Okay, but you cannot simply add things into knowledge base. Okay, as we know, knowledge is something that you get from the experts. Okay, so please be careful. Okay, when you want to add something, whether you want to use the existential or you want to delete the existential. Okay, we delete this as an existential because we don't want to accidentally draw other inferences. Okay, so if you add this, it's easy for you to add a constant into X. Okay. Alright, so let's look at one of the exercise example here. Okay, this is one of the research we have here. Paddy disease diagnosis. Okay, everyone can determine Paddy disease based on period of time, location, and its physical identity. A person can recognize Paddy disease located on leaf by using its shape, color of leaf, color of inner and outer lesion. If the period of time is 11 until 14 days, therefore it is a vegetative time. During vegetative, there are several diseases exist, such as blast disease and rat virus disease. Blight disease, this is blight. Okay, blight disease can be determined by its shape, either round or spindle, color of leaf and outer lesion, either green, yellow, orange or brown, and color of inner lesion is either grey or brown. During nursery time, a farmer claimed that his paddy field affected by the blight disease because of the leaf showed abnormal. The shape is spindle, color of leaf is green, and its inner lesion is brown. Okay, so this information is given to you by the expert of paddy disease. Okay, so this is the new case. Okay, during nursery time, a farmer claimed that his paddy field affected by a blight disease. So we need to infer to our knowledge base. Okay, after you translate the knowledge, okay, into our expert system. Okay, so we want to refer this case into expert system to know whether it is a blight disease or not. Alright, so if we translate this knowledge, okay, into logic. Okay, we have shape of lesion, color of leaf, inner color of lesion, outer color of lesion, and also what are the disease name. Okay, the paddy disease. So based on the previous slide here, okay, we have this. Okay, if the shape is round or spindle and the color of leaf is green or yellow or orange or brown, the inner color of the lesion, okay, you see here there's an inner color, okay, grey or brown, and the outer color is yellow or orange or brown. We call that as a blight disease. Okay, so similarly with the brown spot disease, you can read out all the specification here. Alright, and if it's healthy, that means there's no shape of lesion. Color of leaf will be green, and there is no information about the inner color of lesion or outer color of lesion because there's no lesion at all. So the disease is healthy. Okay, so this is a normal leaf, there's no lesion at all and it's green. This is a brown spot disease, so you can see that the lesion is actually oval. Okay, and some is round. Okay, and the color is a bit different. Okay, you can see that the line is thicker. Okay, for blight disease, it's more round or spindle. Okay, and the edges, okay, the line is not that thick. Okay, so you need to tell this information into your expert system so the expert system can tell the difference as what the expert do. Okay, now this is an exercise for you. Okay, I will paste this also in the open learning. You need to know, okay, which of these 11, okay, is a fact or a rule. Okay, based on the information that we have from these two slides. Right? Okay. So lastly, you need to know what is the problem in first order logic. Why do we have higher order logic? Okay, problem with first order logic, it only allows a quantify over variables, and variables can only range over objects. Okay, so you can have either all or some. Okay, you cannot simply say, for example, there exists men who can marry up to 4 wives. So how do we say 4 wives in first order logic? Okay, you can say marries some woman, okay, but you cannot quantify the sum into 4. So that's why we have a high order logic. So I'm going to continue that with our last video lecture on the logic, which is video 5. Thank you.